So why am I interested in automation? My interest in automation started in my previous role as a data coordinator. I worked at the UW Carbone Cancer Center as a data coordinator for a clinical research group. And clinical research is just research with data from human subjects. My key responsibilities were I would find a specific piece of data and a specific location from the subject's HealthLink medical record. The data would generally be lab results, information from physician notes, and documentation on the progression of the subject's cancer or treatment side effects. I would then enter that data into a corresponding form for the researcher or companies collecting this data. I dreamed of being able to automate that task because it was repetitive and some of the data was collected in discrete locations. Could have freed up time to audit the data I was working with or improve our existing processes for our data. I then transitioned to my current position as an application administrator, which opened up some opportunities for automation. And the idea for automation started with being asked to do some tasks I don't like to do. And you might be asking yourself, why a shovel in a hole? Well, for me, digging a hole is not a fun task, and I dug a lot of holes as a kid, so I'm a little sick of them, but it was good because my dad and I got to plant a lot of trees. And I do want to clarify, I do enjoy the majority of my job, but there are some tasks that I don't enjoy doing and fall into the bucket of digging a hole. One of those tasks is system testing for an upgrade. It's very important and good for us to do this testing for the system, but it can be a little boring sometimes. Key things about this task are that it is repetitive, reoccurring, straightforward, and time-consuming. And these aspects of it make it ripe for automation. But I'm also interested in software development, and it intersects with my team's need of system testing. I really do enjoy learning, and this new project was a great chance for that. I got to learn a new tool that can be used for more than software testing. And I foresee software development becoming a bigger part of general IT work, and I want to be equipped to work in that environment. So why should you be interested in automation? When evaluating this project, we initially did a cost-benefit analysis to determine if automating was worth it for us. My next slide, I'll do a breakdown of some of the estimates with numbers, but this cost analysis I did includes building a tool from the ground up. For some test automation solutions out there, you only need to do the writing of test scripts. So here's my analysis. So this is an example of an upgrade occurring once each year. So we estimated that it takes about 140 hours to complete a single upgrade's worth of testing at about $35 per hour. So the estimated cost and labor total then is $4,900 for a single upgrade. I then compared it to what it took me to work on the project so far, and then the time I'll spend the rest of the year, and it came out to about $6,500 in total time for me working on this project. And as you can see, the main detriment to this is that there's a higher upfront cost with automation, but then the savings quickly begin to pile up after that first year. And in the second year, we're already seeing savings over time. Testing is better when it is automated instead of manual. So another benefit is that this allows for a small upgrade with minor changes to have full upgrade testing done, when normally we would only do targeted testing for that upgrade. Duplicate or triplicate testing can be done without an increase in labor costs. And if we are seeing issues outside of an upgrade, we can now do broad system testing. This removes user error from running tests and makes them more accurate and more repeatable. This does not remove the human from testing, as a human can review all tests and further investigate any failures in the testing. Automation allows you to improve work satisfaction and allows people to focus on more important projects. So the goal with automation is not to take away someone's job, but to free those people up for other tasks. This frees up time for critical thinking on more difficult issues that you might be troubleshooting, or if there's more important projects or new projects that need to be done, this frees up time for those projects. And finally, you can go past automating testing, the possibility of automating data entry. If our users want labor-intensive repetitive tasks done, it's a lot easier for us to say yes when we have a tool that can automate those tasks. This past year, students had to update the zip code for hundreds of subjects in our system, and this could have been done using automation and saved time and money. Fortunately, my tool isn't to the point of doing data entry yet, so we couldn't use it. My cost-benefit analysis earlier did not take into account using this tool for other applications, And as the scale of data increases that you need to update, the cost analysis gets better for automation. And finally, if we want to keep up with other organizations, we will have to start automating tasks. So now I'll get into some of the project details. The application that I did automation with is Encore, a clinical trial management system. The core features of it is that it handles protocol documentation. So documenting reviews from groups such as an IRB or internal review board, managing protocol documents, and then managing the staff associated with that protocol. Subject and specimen documentation, so things such as managing research study participants' visits when they come in to see the physicians and the nurses, the details of specimens collected, and then also shipping of those specimens. It includes research billing information, which is procedures and labs associated with each of those visits that the subjects come in for, and then also fees associated with a research study, such as startup or closing costs. And then finally reporting, because we need tools to get any of that information out of the system once we've put it in there. I started by brainstorming what features the project would need based off of the application of Encore. I needed to be able to take in many test scripts, over 10. The reason for this is that we have over 10 test scripts that we run through, and I needed to be able to accommodate each one of them into this single application. I wanted it to be easy to manage the software after it was in place. So if there's a web application user interface change, if there's some interface changes to the website, I want the script to change and not the underlying software so that it can still function with it. I considered if script writing should be accessible to people with or without software knowledge. I wanted to be able to do data entry in the future. And then I also wanted no user intervention after the testing was initialized. So once play is pushed for the software, it just runs. So the constraints and features I ended up with are the constraints. Needs to be something feasible for me to create with my knowledge. Needs to be small enough for me to create it in less than a year. It needs to be something free. And for the features, needed to read test scripts not made by a developer. Needed to interpret and then execute test scripts in a browser-based application without being managed. And then needed to record successes and failures and then export them in a consumable manner. With that list, I did research to find the various tools that we could use for automation. There's a whole slew of tools to be used for different types of automation. I'm going to talk through a couple and use the example of talking to your friend who's at a different house as the base example. It's not perfect, but I hope it gives you an idea of how the different tools function. So an API or an application programming interface, these are great for sending data to an application or retrieving data from it. It can be very precise and you don't have to worry about a user interface. So an example for this would be if you want to talk to your friend who's at a different house, this would be sending them an email. You can transmit information back and forth, but you miss out on some of the context of talking to them. Next one I investigated was a browser IDE or integrated development environment. So the software is already integrated into the browser. This is fantastic for some testing or data entry purposes, but it has some limitations in what it can do. If you wanted to talk to your friend who's at a different house, this would be calling your friend on your cell phone to talk to them. It isn't necessarily as efficient as an email might be, and you can't see them, but still is great for communication. And then finally, I investigated WebDrivers, software that can interact with a browser from your computer or from a server. It requires software development where the browser IDE does not, but is very similar. This would be if you wanted to talk to your friend who is at a different house. This would be doing a video call with your friend. You can physically see them and talk to them. The user doesn't experience the difference, but a video call is more difficult than an audio call from a technical perspective. I did testing to determine the best solution, which for my case was Selenium WebDriver. So I'll kind of describe how it works now. You write a program using Selenium. In my case, I have script files that are CSV files that are then interpreted by my program and executes code using Selenium, which is this first square here, which then sends it to the browser driver. A program communicates to the browser driver on my computer, and then finally that browser driver communicates to the web browser. The web browser can then communicate back to the browser driver and then back to my computer and my program. And that cycle continues back and forth as you navigate a web page. Another part of this is that there's a unique browser driver to communicate with each browser. The nice thing about Selenium is that it is able to interface with all of them. And so I can pull out this middle piece here using Safari or Firefox or Chrome, but then both ends don't change, just this middle part. Well, the right end also changes because if you're using Safari driver, using Safari browser, but the left half doesn't change. I can use still my same program. So I'm going to give some web browser details. A web page is composed of elements written in HTML, which is hypertext markup language. And WebDriver uses the HTML to identify elements and then interact with them in the browser. So this example is from Amazon. This is the HTML of the element where you type in your search. I highlighted a couple of key things here. This input it identifies what you can do with the element. So here it's an input field, it's a text box. And then common things we use to search for them using Selenium is the ID or the name. And so these are both identifiers I'm highlighting that you can use to find this element on the web page. And so Selenium uses the WebDriver to click and then enter information into the web page. I could use Selenium to navigate to the website, find the search field element, and then enter some text and run a search by clicking enter. And that's all without my interference. Here's an example test script that I've written. My program interprets this and then executes Selenium code. So the first column describes what each row is doing. The second row on gives additional details necessary to perform the actions. So I'll just kind of run from the bottom to top and describe them. So the comment is just reference for me or for someone reading this. It describes what you're doing or going to do using the script, and it doesn't do anything in the browser. The next action is browser. This indicates the type of browser you want to open. Currently, I've set it up to use Firefox and Chrome, which are the two most common ones we need for our program. F is for Firefox, and when I want to use Chrome, I use C. Then website. So this is where I specify the URL. And so I can then navigate to that URL in the browser that I've opened. And then input is where it gets a bit trickier. So columns 2 and 3 are the action details element identifier and the element details. So earlier that example from Amazon, I showed you the search field on the Amazon website. So here, similarly, I would find the element with an ID of username. And then once I find it, I'm entering the text of the username. After that text is entered, I then hop down and click the submit button. So I'm finding an element with an ID of submit button and then hitting enter on it. And then I do the same thing for the password, where now we've advanced to the next screen, and now I can input the password in the appropriate field and then click the submit button again. And then I also added wait because loading has to happen in web browsers. Unfortunately, the web browser doesn't keep up with the Selenium program sometimes, and so there has to be waits to allow pages to load. Eventually I had to dive into software development and figure it out as I went. I did start using my program prior to all the functionality being complete, and then I've added features as I needed new tools from the testing script. I had a testing environment to allow for rapid testing. So this ensures production data safety, and I could quickly iterate the program, allowing for quick improvements to it. And it was important to not have planning paralysis. Eventually, after enough research, I did have to start doing the project. And I learned a lot from doing that rather than just the planning and learning part, which gets into the lessons learned from the project. If your background is not in software development, there's a lot to learn. My education was biomedical engineering. Prostheses is like one of the core features of that. So everything I used related to this project is self-taught. I had to spend a lot of time learning, and time learning is not time coding. And it seems even my own time on the weekends outside of work. Thankfully, we have access to LinkedIn Learning, which is a fantastic tool, and I've used it for the foundation of my knowledge. And I'm actually still using LinkedIn Learning to figure out some new tools that I can use on this project. Software development is hard when you're fitting around your schedule. So my core responsibilities are as an application administrator, which involves application support. And we have hundreds of users on my team that we support across several applications. A small portion of the time that I get to spend each week is working on this project. And I had to be really intentional about blocking off time on my calendar to make it happen. Otherwise, it would be pushed to the side for other projects we had going on. And I'm gonna get 2 or 3 times a week to work on this project, which made documentation even more important than normal. I do leave good comments because sometimes I don't know the next time I'll get to come back to what I'm working on. So it's helpful to have those comments for when you come back to be able to refresh yourself when starting that programming again. I've learned that there's not a one-size-fits-all solution to automation. What I did is great for automating user testing. But again, I talked through a couple of different examples of APIs, browser IDEs, or web drivers. APIs are great if you're trying to send data or retrieve data from the system and don't need to worry about a user interface. The browser IDE is great if there's some smaller testing you need to do or a very specific thing you need to replicate. It's great at doing that. And then the web drivers are a bit more work than the IDE, but are great for testing and data entry and just have more features in general. Another thing I learned is that there are software development design patterns that can be used. A lot of other people have done the hard work of creating design patterns. I just need to learn and adopt them. So some terms I'm going to throw around that I'm going to just define real quick as a class, which is just a type of thing. So a class would be shirt. Just shirts in general would just be shirt. And then an instance or an object would be one example of that class. So Brian's shirt would be an example of an instance of the class shirt. And these terms are relevant in object-oriented programming. And these design patterns help you arrange classes which represent your objects more efficiently. The main goal being to make your code as simple as it can be. I'm in the process of learning these design patterns so I can determine which ones to use for our application. And while there's a working tool, I look forward to improving it to increase its scope, capabilities, and ease of use in the future. And I'll actually cover one of them here. So this is an example of an observer pattern. Common use for the observer pattern is maintaining a list of subscribers to something such as a newsletter or magazine. In our example, think of a company with many subscribers and many magazines that they manage. Each concrete observer, which is the bottom left portion, is an instance of the class observer and will be someone subscribed to a magazine. The details for that person is in their own self-contained object. And so the magazine, each magazine is not concerned about what the address or details of the subscriber is. Each subscriber has their own object with their own information. And then one of the magazines is an instance of the class subject. It just wants a list of all the subscribers to that magazine without their personal details and the ability to add and remove subscribers from that list. And then when it's time to send the magazine out, it just calls each one of the observers to notify them, or each one of our subscribers to notify them. This helps with data organization and prevents overlap of responsibilities or duplicates. Because if you have 2 magazines, you don't want each magazine to have a different copy of the subscriber's information. You just want it to have the subscriber with the subscriber's information listed somewhere else. There are a lot of different design patterns. Some of them are really complicated. Some of them are simpler. But it really just depends on your situation, which design pattern you want to use. Then finally, writing test scripts and software development is a lot of work and I needed extra help. So right now I'm receiving 2 forms of help. A software developer is giving me guidance on how to improve the software. And then there's a student who's going to help me create test scripts. I also want to call out some key people who have helped along the way. So my manager, Mark Bueller, he's helped me bounce a lot of ideas off and allowed me to have the schedule to be able to work on this project. We had a student intern, Henry Andera, who at the onset of the project was able to help with figuring out Selenium, how it works. And then finally, Brent Clark, who's a software developer on our team. He's been providing advice on how to improve the application. Because my time and knowledge is limited, so I've had to pull in others to help improve the software and move the project forward as necessary. Next, I'll talk about how you can do this yourself. So you'll want to identify an area where there's a need and there's significant chance for impact. Think about your current work tasks and determines which ones fall into any of these categories. Things that are repetitive, reoccurring, straightforward, or time-consuming. These are tasks that are ripe for automation. You want to assess the potential benefit with the cost analysis and use this in making the decision. Try to get some estimate based on the hourly rate to do something and how much time is spent doing it. This will give you an idea of how much it costs to do this thing. Determining the cost for automation is more difficult because it's reliant on which tool is used. But if the task is something that requires a lot of time, consider automating it, especially if this is a long-term reoccurring task. It should be considered for automation. And once you have found the tool, it's easier to do a cost-benefit analysis, which gets into determining what the right tool for your situation is. I will cover the three again: APIs, WebDrivers, and browser IDEs. Those are kind of the core ones for web automation, but there are numerous other software solutions offered by companies or general applications, some of which cost money. And it's really helpful to do this after you've determined the scope and needs of the project you have. Then finally, educate yourself on the tool you decide on and start the project. After you've made the decision on a tool, figure out how much time each week you can work on it and start educating yourself. LinkedIn Learning has great courses covering all kinds of programming and applications, and we get it as UW employees for free. You can create a design, plan for the project, and start working on it once you have some information. And it's okay to not have all the knowledge in the beginning. You can learn what you need along the way. So now I'm going to do demonstration. I'm going to describe first what I'm going to do, and then as it's happening, I'll continue describing it. So we're going to be doing one small portion of one of our test scripts. So we will open a browser. We will go to our test environment in Encore. We will log in. We will be going into the PC console and creating a protocol. The PC console is the central location for managing information. The central location for managing information about a protocol. This is more about documentation about the protocol than clinical information. So you can get to patient information from it, but it's not its main purpose. We will attempt to create a protocol without filling out the proper fields, and we'll get an alert to show up. They will then enter the needed data and create the protocol. We will navigate to a different tab on the protocol and make some updates involving pop-ups. We will then save the changes and we will close the browser. I'm going to ask that people don't take any screen captures during the demonstration, as this is vendor software that the demonstration is going to be happening on. And I'll get it started. Here we go. It takes a second to load, and then I'll drag it over as soon as it starts. There we go. Hopefully everybody can see that. So right now we're entering the username. And it's running slower than it normally would because I want us to be able to see it. Normally it flies through these screens and it's hard to keep track of what's happening. So we just entered our password. And we are now into Encore. We're going to go to the PC console. And then we're going to create a new protocol. And there's the alert I talked about. So the submit button was clicked very quickly. And we got this alert to show up now that accepts it. And it starts entering data onto the protocol so that it can be created. All right, we'll close it, and we've created a protocol successfully. And now we're going to go to the management tab. We're here, and then it's going to update some information. And then it's going to get some pop-ups, which I'll probably have to drag onto the screen so that you can see them. It's going to be updated the administrative groups across the bottom. Here we are. All right, here's one of the pop-ups. And again, this is normally much faster, but I'm just wanting us to actually be able to see what's happening because it normally happens very rapidly. Here's a second pop-up. All right, just click select, and then another pop-up. I think this is the last one. Click the submit button, and it should close it in a second here. And then the protocol's been updated, and we updated some fields with pop-ups, and that's it. And it closed the browser automatically. After it does that, it then exports it to a file that I can then read later to determine which steps in the script succeeded and which ones failed. And now time for questions.
Okay. Thank you very much, Brian. That was really interesting. One of the questions that I have is, what challenges did you have to get here? Like, yeah.
I would say this. There's a slide I called out "Software development is hard." Not having a background in software development, there was a lot to learn, especially learning Selenium at first. Just learning, like, allowing the web page to load at times was difficult because I would put in a string of commands and it would work sometimes, but not all the time. And then I realized it was because of loading delays. And so thankfully Selenium allows for that margin of error in loading. And so that's something you can put into the program to enable it to do. And so when I added that, that helped a lot. But just it's like learning a new language a little bit. So it was difficult to pick up Selenium and start using it fully initially.
How long did it take until it got like going?
I think from when I could really start working on the project to when I had like my first test script running, I would say was probably about, well, not a full test script, even just part of a test script was probably about 4 or 5 months, I'd say. Just having a couple hours each week to work on it.
Okay, sounds good. Now we're running out of time. If there are, oh, there is one more question. What would you do different if you had the chance to start again? So if you can briefly explain this.
Yeah, I think incorporating design patterns at the very beginning. I used Python, which is an object-oriented language, and I did use some objects in it. But I do wish I had known some of the stuff I know now about design patterns, because it would have saved a lot of time, and I think that it would have overall been a better application. Thankfully, I can still like make those improvements moving forward, but it would have overall improved it from the beginning, I'd say.
Okay, sounds good. All right, thank you very much, Brian. Thank you, everyone who attended today's session. There are still other sessions going on after this, so make sure to check them out. Other than that, have a great rest of the day, and thank you.
Yep. Thanks, everybody.